Hello. Today we're going to keep going through connecting representations. Hopefully everything made sense for last lesson, and this is kind of the same kind of thing. But we'll talk about it now. Let's have a look. So, just a quick starter. For each of the following linear relations, state the start value, which is the initial value, and the rate of change. We're not going to do units, so let's see if you can do that, and I'll go through it very quickly. Okay, so just a quick reminder then, all lines are in the form of y equals mx plus b, or should be in that form. There is a number with a letter, and there's a number on its own, right? The number on its own is always your initial value, and this one here is called the slope, or the rate of change. So we have the initial value is the number on its own. The rate of change is the number with the other letter, if you will. So it'll be like X or T or whatever. So if we look here, what I'll do is I'll make red be the rate of change, and I'll make blue be the initial value. So for this one, 2 is the rate of change. This one is -2. This one is +40. This one is 10. This one is 125. This one is -2/3. This is -9.8. And this one doesn't have a slope, NA, because there is no number with another letter, right? So it doesn't have a slope. For the initial value then, the initial value here would be 50. The initial value here is still 50. This one's 350. This one's 25. This one's -30. This one's -90. This one would be 0. And then this one is 16. And that's it. That's it. That's understanding y equals mx plus b, really. That's everything you need to know for that. Okay, let's have a look at some questions and what we're doing today. It says, write a linear equation for each of the following. So this is going to be, again, just a quick reminder, it's y equals mx plus b. So the rate of change is always in front of the x. The b is always there, and the number on its own. So this is going to be y equals 35x plus 10. This one is y equals -80x plus 75. This one is y equals 5x plus -3, but in general we don't write plus minus, so it should just be y equals 5x minus 3. And then this one is y equals 1/2 x plus 0. You don't have to write the plus 0, that's just the way it is. So y equals mx plus b then, should be comfortable with these kind of words, rate of change or slope or m, all mean the same thing. And then should be also comfortable with the phrases like starting value, initial value, y-intercept. They all mean the same thing as well. Okie dokie. So, we're going to go through 3 sets of questions, and then we're going to basically talk about what the representations are again. So here we go. A taxi. Have a go at this question if you can, and then I'll go through it. A taxi service charges an initial fee of $5 plus $2 for each kilometer traveled. So before I even read any more of the question, right, there's an initial value here, and there's also a thing that's changing. So instantly, I know that this is my initial value because it even says it there, initial value, and I also have something for each or pair, or it's something that's changing, right? So it's $2 per kilometer traveled. Because I know that is your M. And because I know this is your B. So without even doing anything else, I already know that my equation of my line is y equals 2x plus 5. Some teachers are obsessed about like using the right letters. So maybe they'd be like, oh, cost is 2 times kilometer plus 5. I don't really care about that. I mean, as long as you know the equation, right? Anyway. So, complete a table of values showing the total cost of hiring taxi service for 0 to 5 kilometers. So we have our kilometers are going to be here, and then our cost is going to be here, because our kilometers are independent. Cost is dependent, right? Cost is dependent on the kilometers. And then what you do is you go, okay, I've got 0 kilometers, 1, 2, 3 kilometers. Like, I'm not going to do all the way down. And then what's the cost? Well, the cost for the initial is $5. For 1 kilometer, you're going to add another $2. And then you're going to add another $2, and you're going to add another $2, and it looks something like that. Sketch a graph to show the total cost of using a taxi for a distance of 10 kilometers. We know that 10 kilometers is going to be, well, if you keep adding $2, right, and you kept going, you would get to 25. But even if you weren't entirely sure, you could just put 10 into here, couldn't you? So it'd be 2 times 10 plus 5. So we know it's going to be 25 for the 10 one. So our graph is going to look something like this. It's going to start off at $5, and then at 10, it's going to be at, what did I just say, 25? So our graph's going to look something like that. Identify the start value, done that. That's 5. Rate of change is 2. Create an equation. Again, this one has like using the letter C. So some teachers will be like, oh, the C has to be 2D plus 5. But I don't know a teacher that wouldn't give you the mark for y equals 2x plus 5 as well, because they mean the same thing. Use one of your representations from part A, B, or C to determine total cost of a 50-kilometer ride. We're going to go ahead and put 50 into here. So it's going to be 2 times 50, which is 100, plus 5. So it's going to be $105. Cool. I've got this one. Okay, a full jar of candies contains 60 candies. Each day 4 candies are removed from the jar. Do 0 to... So again, there's your initial fee, isn't it? That's the thing that's starting, initial value, initial cost, whatever you want to call it. This is the thing that's changing. It's 4 candies removed. So already, I don't even need to think much. I already know the equation. It's going to be y equals -4, because it's losing 4, right? -4x plus 60. My values from 0 to whatever. So this is going to be days. Oh, is it 8? Oh, it's not. Doesn't want to write days, and then I guess candies. Candies, very topical with Halloween. For the 0th day, there was 60. For the first day, there's 56, because they're taking away 4, right? Second day is 52. Third day would be 48, etc., etc. Keeps going down. If I sketch a graph of this, first of all, we want to know how many days it would be. But like, if it's going down by 4, we know it's going to be 15 days, don't we? Because 15 times 4 is 60. So our graph's going to look something like this, where that's 60, and our 15 days here, and it looks like that. Cool. Initial value is 60. Rate of change is -4. Create an equation, done that. For what value of t does your equation apply? And as we've just done it, it's 15 days. The reason it doesn't apply anything after that is because on the 16th day, there would be no candy to take. What are you taking it from, right? So that's where it stops. So what does it start for? 15. Okay. Have a quick look at these questions. Question 4 was actually the starter, so we'll leave that one there. Question 3, can you create an equation for these things? Have a go. Okay, so equation for this one then. Again, the rate is the one that goes in front of the x, so it's just y equals 3x plus 8. Y equals -20x plus 540. Y equals 5x plus 0, and then y equals 0x plus 30, which in general, you don't really say 0x, do you? So you just say y equals 30. Okay, and same for the y equals 5x plus 0. You don't really need to say the 0 either. But hopefully that's easy. Hopefully that's wonderful. Let's move on. Okay, so as you kind of gathered so far, this lesson is just a recap. We're going to go over every single representation. We're going to see what the formulas look like. And if you need help, this is obviously the lesson I use for teaching, but this is the time to make sure, right? So before this lesson finishes, make sure that you're comfortable with everything here, because we're going to basically use this a lot, this information. So let's have a look. Okay, so representation. If you are given a graph, there's 3 things that you should be able to find from it. The first thing is the rate of change. How do you find the rate of change? You pick 2 lovely points on the graph. It doesn't matter where they are. You just pick whatever points. So for example, here, that's a lovely point, and it's a point because I can see both the x and y values. And here, for example, we draw a triangle. Notice how I don't care if the triangle's up or underneath it or not. We count to see what actually is happening here. So it goes from 13 to 10, so it went down 3. And then it's going from 50 to 125, and so it goes across 75. And then it's always rise over run, isn't it? It's rise over run, which in our case is -3 over 75 or -1 over 25. If you want to simplify it, just divide them both by 3 there because it's divisible. So rate, -1 over 25. Your initial value is when x is 0. So when x is 0, which is here, what is the value for our graph? And there it is, isn't it? It's 15. If the line didn't go all the way to 0, like let's say it was just like this, right, and it didn't come back, you would basically make sure that it did go back. And you'd be like, okay, like what would it have been? So it has to be where it hits the line of the y-axis, not anything else. Because in the same way, lines can be even further, can't they? They can go even further back. Some people think over here is the initial value. No, it's always where it is on the y-axis. Okay, if you can find the rate of change and you find the initial value, you find the equation, don't you? It's just y equals mx plus b. It's y equals negative 1 over 25x plus 15 in this case. Okay, have a go. Okay, so what's the rate of change for this place? Well, pick two nice points. I don't know, like here and here. Draw a little line like that. It went 3 up. It went 1 across. I know it looks like 2 squares, but it's from 1 to 2. So it's only that. Only one whole thing and 3 up, yeah. That means my rate of change is going to be 3 divided by 1 for my slope, which is just 3. My initial value is 1. So my equation of my line is y equals 3x plus 1. Cool. What about this one? Slope, I don't know, this point here and this point here. Notice how I don't actually care as long as it's on a nice point. We went from 4 to 12, that's 8. We went from 8 to 24, that's 16. So my slope is rise over run is 16 over 8, which is 2. My initial value is 0. So my equation of my line is... I would like a pen back, please. What's it doing? Yeah, good. So my equation of my line is y equals 2x plus 0. And then last but not least, I'm going to zoom in a bit more for this one because it's a bit of a weird one. Pick two nice points. I don't know, here because it's 70, and where else? I guess here. Draw a triangle. It went from 70 to 50, didn't it? So that's negative 20. It went from 0 to, what is that? Well, if you're not sure what it's going up in, realize that it goes from 0 to 16 and 2, which means each little gap is 8. So we know we're just going to add 8 for each gap. So 32 goes to 40. So we went from 0 to 40, which is 40. And then remember, it's always rise over run. So in our case, our slope is going to be negative 20 over 40, or just negative 1 over 2. Our y-axis is 70, so it's y equals negative 1 over 2x plus 70. Cool. Hopefully that makes sense. Hopefully that was wonderful. Let's have a look at the next one. Okay, what about if I give you a table? Whoa, how can I find the rate of change for a table? Well, what you do is you find out what's happening on this side. So they're going up in 2s, aren't they? What's going on this side? It's going down in 4. So rate of change is always rise over run, or in this case, y over x. So it's negative 4 over 2, which is just negative 2. My initial value is when x equals 0. Here it is. There's my x, right? Because it's always xy. So there's my x equals 0. So what value was it? It's 20. So then my equation is y equals negative 2x plus 20. Again, what can happen in this one? It could not have a 0 value, and then what you have to do is you have to use your rate of change to basically keep going back. So imagine it didn't have 0, 20 here, but you only had 2 and 16. You would know, because I want to go back to it, I'd have to add 4, right? So that might happen. Anything else? No. For the rate of change, or if I ask you a question on this, the rate of change will always be consistent, right? It will always be linear. So it won't happen where it's not. Okay, I think that's everything for this one. So have a quick go. Okay, so rate of change for this one. This side's going up in 1s. This side's going up in 30s. So rate of change is 30 over 1. So my equation of my line is y equals 30x plus 20, because that's the initial value. For this one, this side's going up in 10s. This side's going up in 150. So we do 150 divided by 10, which is 15. So equation of my line is y equals 15x plus 100. What's going on this one? It's going up in 5s. This one's going down in 20. So negative 20 divided by 5 is negative 4. So it's y equals negative 4x plus 110. And then last but not least, this side's going up in 20s. This side's going up 124. The slope is going to be 124 divided by 20, which I believe is what? It's 6.2, I think 6.2. So it's going to be y equals 6.2x plus an initial value is 0. Okie dokie. Cool. Let's do the last thing. Is it the last thing? Either it's the last thing or second to last thing. What about if it's words or other things? Again, we've talked about this previously, but whenever you see something per something or something for each something, that is your rate of change. So our rate of change for this one is 50. Initial value is 1,000. So y equals 50x plus 1,000. Pretty obvious what if it's in the form of an equation, because again, mx plus b. So the rate of change is 30. Initial value is 260. And there we are. Okay, have a quick go at this, and then we'll briefly talk about the hardest kind of question, and then that's it, that's the end. Okay, initially only one person in a small town infected with a virus. I don't know about you, but just talking about viruses upsets me since COVID. With each passing day, the number of infected people doubles. Create a table of values to show the number of infected people in the town from 0 to 7. So, this is an interesting one. So we have on the day 0, we have, so we'll put day here, and we'll go infected. On day 0, there's only one person, and then it says it doubles each time. So day 1's going to be 2 people, and then day 2 is going to be 4 people, day 3 is going to be 8 people, and etc., etc. Notice very quickly, by the way, this means it's not linear, because it's going up in 1, going up in 2s, going up in 4s, and it's not the same going up. Use your table of values to sketch a graph. If you sketch it, it would look roughly like this. Because the values are double, it looks like it becomes a nice curve. Is the relationship between the number of infected and the number of days linear or non-linear? It is non-linear because it's not going up by the same amount. That's 1, that's 2, that's 4. They'd have to have the same gap to be linear. Calculate the first differences. What do you notice? What do you notice? It's doubling. Suggest an equation. You're not supposed to know what this equation is yet because it's non-linear, but effectively it's y equals 2 to the power of x. That's it. Because it's doubling, so it's 2, and then it's like 2 square, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, right? So that's just what it is. And then last but not least, equation, the equation C equals 30 plus 85t represents the total cost in dollars of renting a jet ski. Describe the parts that make up total cost. So you've got an initial cost of 30 is initial cost. So I'm guessing that's your initial deposit. And then it's 85 times is your rate of change, isn't it? So it's it's $85 per hour is what that is. So $85 per hour. Bucks per hour. There's not really much else to say about that. Okay. And then last but not least, these, we don't have to actually go through them, but it's a perfect example of them not giving you the initial value. And so what you do is you just go back with it, right? So this one here, you find what the rate of change is. So the rate of change is 8.7? And so then you just take away another 8.7 to get your answer. So it's going to be 6.9, is it? So that would be my initial value. Here, notice how it's every 20. Right? So you would do the same here, recognize what's going on. So it's going down 290 for every 20. So then you're just going to add 290 to get your 0 value. Here, it's going to be 0 for the next thing, isn't it? So it's a bit of a weird graph, really. You don't really tend to do the x-axis going down, but it doesn't matter. So every one, it goes down 123, doesn't it? So it's going to be 77 for 0. And if it's a weird one where you can't even really work it out, you actually have to find what the rate of change is and then go back independently. So here, for every 5, this adds, what's that, 41.5, is it? No, 41.5, yeah? Is that right? 41, yeah, I think so. 41.5, yeah. No, it can't be right. It's 41.5 and then 41.5. I'm having a moment. Hold on. Sorry, I've just got to text my wife. Negative, so 338.0 take away 380.5. 42.5. There we go. I knew something wrong. Couldn't figure out what it was, but there we go. Okay, 42.5. Yeah, okay, now life's better. I'm back being happy now. Anyway, right, so 42.5 divided by 5, right, would be what it is per thing. So that's 8.5. So per 1 is 8.5. So you just go back 2 lots of 8.5. So we'd add here another 17. Or so I say subtract another 17. And then you'd have 397.5. What would be my answer for 0? Anyway, hopefully that makes sense. I kind of went on a bit of a tangent towards the end there. Apart from that,